David Ken here with another question from your Hayes and Harris Math SL textbook. This is Chapter 8C.1, Question 5, Part D. In this question, what we're doing is we're trying to find the obtuse angle that has the same sine as these angles. So basically what we're doing here is we're dealing with transformations on the unit circle. So let's draw the unit circle. So there's the circle. We'll put some axes on this circle as well. And maybe we'll copy this, because we'll use it again and again. Alright, let's start off by trying to solve part 1. And part 1 says that we have an angle of 45 degrees. 45 degrees looks like this. That's 45 degrees. Now what we want is an obtuse angle. This is an acute angle, so we need to go past 90 degrees to get an obtuse angle. And we want it to have the same sine as 45 degrees. Well, 45 degrees has a certain sine component. It has a certain vertical component. The sine of 45 degrees is the height of this red line. We want to look for an obtuse angle that has the same height. So we want to go over. Everything on this green line has the same height, but only here is another angle. This angle is going to have the same height as 45 degrees. And so it will have the same sine as 45 degrees. So what we want to do is we want to find that angle. Well, this angle is 180 degrees and then go back 45. So this unknown angle is 180 degrees, go back 45 degrees, and that gives us 135 degrees. So this angle is 135 degrees. Let's try another one. I'll skip part 2. Let's go to part 3 so we can work in radians. Alright, in radians we have an angle pi on 3. That's a third of pi. Pi is halfway around, so it's a third of halfway around. It's going to look like this. That's the angle pi on 3 radians. And again, we're looking for another angle with the same side, but which is obtuse. So it's going to have the same height. So it has to be on this green line, but it has to be greater than pi on 2, greater than 90 degrees. So that's this angle here. That has the same height as pi on 3, and we'll calculate it the same way, by going all the way out to pi, and then reversing pi on 3. So that's all the way out to pi, but take away pi on 3. So a whole take away a third leaves 2/3 of pi radians. And that'll be the angle, the obtuse angle, that has the same sine as pi on 3, 2 pi on 3.